we're going to hear from Juergen Hoeller. He's obviously the co-founder of Spring. He's going to tell us all about what's happening in Spring Framework.
Hello, this is Juergen Hoeller, speaking in my role as the Spring Framework co-founder and project lead, reflecting on the evolution of Spring in the current Java ecosystem. This is a very exciting time in the Spring community, with many trends and efforts and work streams coming together, redefining our understanding of what a modern-day Spring application may look like. But first, let's talk about Janus. Janus was the Roman god of beginnings, gates, transitions, time, duality, doorways, passages, and endings. He is depicted as having two faces, looking to the future and looking to the past. The Spring community is facing a similar duality at this point. We are catering to a large user base with existing production systems out there, on legacy infrastructure, and all on a wide variety of infrastructure out there. But we're also anticipating architectural trends and the future evolution of the Java ecosystem. Typical example for our need to look backwards is the current production scenarios out there. The choice of Java version is a strong indicator. Java 8 totally dominates the market 6 years after its release. Despite Java's new release cadence, where a new OpenJDK release is brought to the community every half year, we have a similar situation in the Spring user base. A strong Java 8 dominance, a strong uptake of recent Spring Framework generations, running and developing against Java 8. But there's also a noticeable trend towards Java 11 as the latest long-term support release. And there is a dedicated community out there following the latest OpenJDK releases, which is also a first-class model in OpenJDK's new release cadence. Beyond Java infrastructure generations, there are many other tensions out there in the Spring ecosystem. Enterprise architects in large corporations, they tend to have a very different mindset compared to, say, software startups, where a development team is working towards a proof of concept to be rewritten soon. Whereas, of course, in the enterprise world, a lot of the code being written there has a very long lifetime attached, needs careful evolution of those systems, being considered from very early on, handoffs to other development teams and so forth. Corporate servers in data centers also managed very differently compared to cloud hosting solutions, where depending on your cloud provider, there's a very specific policy attached, technical constraints. There's many factors that come back to our software architectures and need to be considered in our development processes. There's, of course, a good old candidate as well, the choice between a monolithic architecture and a microservice architecture. They say these days there's also something in between, a kind of modular. There's many ways of designing our larger scale system architectures these days, but the trade-offs being chosen are very different. And we see strong trends, but different trends in different directions coming together here in the Spring community. In those past 16 years, that Spring has been serving to support real-world application architectures out there already. There are very different configuration styles with us. Like back in 2004, it was all about XML configuration. Whereas just a couple of years later, the mainstream turned towards a declarative model, annotation-based configuration, where the traditional structures to some degree were embedded into the application source code itself. A couple of years later, once again, Spring Boot changed the landscape completely. We are now working with self-contained deployment units, embedding our web servers instead of deploying a WAR file to an application server. And then fast forwarding another couple of years, we saw a recent trend towards programmatic configuration mechanisms, kind of turning around the declarative configuration model again, making configuration structures very explicit, programmatic, discoverable in the source code. This is particularly common with reactive architectures, where callback style programming is also being suggested by the reactive streams model, where it's kind of a natural companion in your design toolkit. But it's not limited to it. You may code all sorts of architectures with modern day Spring in a programmatic fashion. Now, we've been looking backwards quite a bit, and there's a long history that Spring brings with it. Let's switch gears and look forwards. What's coming our way in 2020 and onwards? Let's start with OpenJDK itself. OpenJDK's half-year release cadence has a model in place with many interesting projects shaping up that are being brought to us every half year. There's Project Loom, there's Project Valhalla, there's Project Laden. They are being released whenever they are ready, but fortunately, there's never a long gap if they are not making a particular OpenJDK release, such as 15, we might make 16, half a year later. The project formerly known as Adopt OpenJDK, it's now named Eclipse Adoptium, provides common JDK builds for the community at large, to a large user base out there, not only for the latest OpenJDK releases, but also for the long-term support branches. Those would be JDK 8 and JDK 11 at this point, and JDK 17 next year. Outside of OpenJDK, there are many interesting initiatives by many stakeholders out there. I'd like to single out Oracle's GraalVM project as a key player. They're really challenging our understanding of what the Java platform is these days, of what it can be these days, not least of it all through its notion of native executables. The Java language and its standard APIs slowly but constantly evolves. The half-year release cadence doesn't bring more features our way, but they bring features our way more quickly. Among the recently introduced features, there are long-awaited ones, such as text blocks, record classes. The JVM itself, the runtime infrastructure, evolves even more actively. And Project Loom's virtual threads are potentially enable new kinds of scalable architectures. From a Spring perspective, the challenge, of course, is to track OpenJDK's releases and the outcome and the impact of all those new projects, new initiatives in OpenJDK, allowing for the evolution of existing Spring applications at their own pace. The upgrade to a new OpenJDK release happens. The corresponding application development team may consider adopting those right into their Spring-based architectures. But we're also, of course, enabling new kinds of architectures for newly built systems. Beyond language features, there's a particular important factor, performance. There might be faster startup, reduced memory consumption for short-lived processes in particular, or for cloud deployment. Or are we optimizing for peak performance? Are we optimizing throughput in a longer running system? There are many recent efforts out there already, in particular in OpenJDK itself. There's class data sharing between Java virtual machines. There's new garbage collectors such as C and Shenandoah. But more dramatically, GraalVMs, the aforementioned GraalVM projects, native executables, provide a quite radical rethinking for how Java applications can be deployed. And this particular model towards native executables in the Java space is about to be standardized in OpenJDK's Project Laden. Now, let's bring it all together into the present. Our upcoming round of releases, in particular Spring Framework 5.3 and Spring Boot 2.4, are designed to bring it all together, to support the many kinds of existing Spring configuration styles from the past, from the distant past, from the recent past, and all those architectures coming with, while also embracing the latest features in the Java ecosystem out there, and in particular in OpenJDK, in particular in GraalVM, providing an initial path towards native executables, providing an initial path towards different kinds of scalable architectures. Looking backwards as well as forwards at the same time, providing a stable foundation for the common architecture styles for years to come, the Spring Framework 5.3 generation is an essential step for us to wrap up the 5.x line. It comes with extended maintenance, as known from the 3.2x and 4.3x branches, supporting not only the currently common JDK generations, but also the upcoming JDK 16 and in particular the JDK 17 LTS release in 5.3x updates next year, leading to a natural upgrade path for all Spring-based systems at their own pace. Thanks for your attention. See you in my breakout session and enjoy the upgrades.